Hey guys, happy Friday. Super exciting seeing you all this week. It was really awesome. One thing that's not so awesome is having Zoom crash lots of times. So if you were a part of that group that didn't get the full lesson, I'm so sorry. I wish I could control that, but here we go. We're going to do a quick overview of what we did in class, including the notes here. So without further ado, let's talk about solving for missing sides using SOHCAHTOA. Remember, we've got these functions of sine, cosine, and tangent, and we can take the sine of a degree of our triangle. So right now, we have a 38-degree angle here, and we're given a couple sides. So the first thing I want you to think about is, how can I label this triangle? I have an opposite side, an adjacent, and a hypotenuse, but I have to be looking at one angle so I can determine what side is opposite and what side is adjacent to that angle. So let's start with opposite. I'm given this 38-degree angle. So what side is opposite? It's the angle that's directly across from what I'm given, or the side that's directly across from my angle. So I'm going to label this as opposite. What's my hypotenuse? That's another easy one. We have to remember that our hypotenuse always looks like that diagonal. It connects my two straight legs. So this is my hypotenuse here. And we're left with one more choice, something called adjacent, my adjacent side. Adjacent literally means right next to. It also means that it's the side between our 90-degree angle and our angle in question, or the angle we're given. So this is my adjacent side. You can think of it like, right now I'm in my office, and my office is adjacent or right next to my spare bedroom. So that's how I think about what adjacent means. So now that I've labeled the sides of my triangle according to this angle that I'm given, I have to decide, can I use sine to solve for x, cosine, or tangent? Well, what am I given? I have an opposite and a hypotenuse. So if I look back up to SOHCAHTOA, which one of those three has an opposite side and the hypotenuse included? Right off the bat, I'm seeing sine is opposite over hypotenuse. So I know that I can use sine to solve for my x. So I'm going to use this function of sine here. So let's set up some ratios. I decided I'm going to use sine of 38 degrees. Sorry, there's a crying dog in here. Hey, buddy. All right, so sine of 38 degrees. And I know sine is equal to my opposite side length over my hypotenuse length. So my opposite side is x, and my hypotenuse is 11. Now you might be wondering, so what now? How do I get x by itself? Well, what I want you to think about is sine of 38. This is just a number. Treat it as a number, as a value. So what do I have to do? I need to multiply by 11 on both sides. So what I can think about is sine 38 over 1 is just the same thing. So I can cross multiply like so. So I'd have 11 times sine of 38 degrees here equals x. Well, now what? Let me see. I don't even have a calculator in here. Hey, that's okay. What I do is I would type in 11 times sine 38 degrees, and I would get about x equals 6.8. Now, if you're typing that into your calculator and you're not getting the same thing, chances are that your calculator is in something called radians mode, which we don't want. We want it in degrees. So there should be a mode button on your calculator where you can change it back to degree mode. If not, hey, send me an email, chat with me about it when I see you next week. It's no big deal. Just means that instead of degrees like we have here, it's using a different measure. All right, so that's how we would solve. We're just going to move straight on with the next part of our notes here for you guys. So I'm given another angle. So let's label my triangle. That's step number 1. So directly across from the angle I'm given is my opposite side. And then my hypotenuse is the diagonal that connects my two legs. And then I'm only left with one, my adjacent side, the side that's connected to my angle that I'm given. So what can I use here? Remembering SOHCAHTOA. The S stands for sine, C stands for cosine, and T stands for tangent. So what do I have? I have an adjacent side and I have my hypotenuse. So let's start with sine and go through the list. Do I have my opposite side? Nope, I don't have a value for my opposite side. I could solve for it, but not right now. I need to find my x. So what about cosine? Adjacent over hypotenuse. Well, look at that. I've got an adjacent side and I've got my hypotenuse. So I could do cosine of my angle that I'm referencing back to. That's how I make up all of these definitions and label my sides. So I've got cosine of 38 equals my adjacent side, which is 16 over x, because that's my hypotenuse. So we're faced with another question here. What do I do with this x in the denominator? I'm trying to solve for x. My first step is going to be getting that x out of the denominator. How do I do that? I can cross multiply. That's always a great choice. But you can think about it just like you would solve any other equation if cosine wasn't in there and cosine was just a value, which it is. I can multiply by x on both sides. So these would cancel, and I'd be left with x times cosine of 38 degrees equals 16. Remember, that's x times the cosine. So what we have to remember is that cosine 38 is just a number. So if I gave you 2x equals 16, how could we solve that? Well, I could just divide by 2 and get x equals 8, right? So don't look at that, not related. But in the same way, I have x times a number. How do I get rid of that number? I want to divide both sides. So my cosines cancel out on this side. I'm left with x equals 16 over cosine 38 degrees here. And then here's another calculator moment. I just have to remember my parentheses when I am typing this in. That's really important. And I get x equals 20.3. So my missing side is 20.3. Awesome. All right.